Hello, Longhorns. This is Miss Clay here. Today we're going to be talking about arc length and the circumference. All right, so let's first get started. We have a circumference of a circle. So first things first, we have the radius. We're going to show that by symbol R. So if you see our circle right over here, a little pin right here, we have our radius coming across. It is half of our circle. Then we have the diameter. This is cut. If we cut our circle completely in half, this would be our distance across it as well. And then finally, we have our circumference of a circle. And our circumference of a circle is all the way around our circle. So the other way to think of it sometimes is the perimeter of the circle. So we've done perimeters of squares and triangles before. So this is a way for you to think of it when we talk about our circumference. So here's a little tip. Look at the letters, radius, diameter, and circumference. You notice radius has the fewest amount of letters. So it is actually the shortest distance. Next is diameter. It has more letters than radius, but less than circumference. So it is greater than the radius, but less than circumference. And finally, the circumference has the most letters. It's going to be the biggest every time. So that's kind of like a little cheat sheet thing to help you remember sometimes. It might help. Okay, we're going to introduce another Greek symbol today. It's pi, and it's shown right here. And it's pronounced pie, like you eat a piece of pie. And it's shown by this Greek written symbol right here. It is actually a ratio. It is the circumference divided by the diameter. And so if you notice on your calculator, if you have the school calculator, you'll notice on the left-hand side, near the bottom where all the letters are, you'll have a little button that has a symbol pi on it. And when you press it, you'll have some other expressions that pop up, but pi will be the first one. So if you tap it and press enter, you'll notice that it is 3.14149, okay? If you notice that. If you have another calculator, you just have to look for it. It's there. There's always a pi symbol on any scientific calculator, okay? So here's a little tip to remember our 3.1159. May I have a large container of butter today? Well, not necessarily the cutest saying, but if you count the letters, May, 3, 1, 4, A, you get the point. But for our exercises, all we usually have to remember is 3.14. If you type it in the calculator or if you use the symbol in the calculator, it'll automatically carry out to these significant digits, okay? So let's move on to our next one. So if I told you pi was the circumference by the diameter, well, then we also have figured out another expression or formula for circumference. So circumference is equal to pi times the diameter. So I'm showing it here again so we can get really comfortable with it. And I have our center right here so we know that the radius goes from the center of our circle out, okay? So what do we know about the diameter? What have we discussed about this before? So we also know the diameter is equal to 2 times the radius, right? We've discussed that before. So I can rewrite this formula to be the circumference is equal to 2 times the radius times pi. Okay, so now we have two options in which we can find our circumference. So if they give us the radius, we'll use this formula. But if they give us the diameter, we'll go on and use this one, okay? So let's do a couple examples real quick. Really easy. Find the circumference of each circle. Leave your answer in the terms of pi. So that means we don't have to finish solving the complete part of it. We just need to leave it in our pi term. So remember our formula. So this first one we have circumference is equal to 2 radius and pi, 2 times the radius. So all we have to do is 2 times 9 times pi, because it told us we have to leave it in terms of pi. So all we have to do is 18 pi circumference. All right. Now for our diameter, we have the circumference is equal to pi times the diameter. All right. So the diameter is 15. And And so all we have to have is 15 pi. Okay, that was easy, right? Moving on. Let's do our arc measure. So we were introduced to arcs yesterday, right? So now we're gonna build on it a little bit more. So if we look at our measure of our arc, the measure of an arc is equivalent to the measure of its corresponding central angle. So remember on the other side, I said that this is our central point. So this is what it's referring to. Our central angle comes from our center point. So if this angle right here is 32, that just means that this arc right here is 32. So the measure of BC is 32. All right. Well, look at this one. This one gives us the measure. Well, we know that these two are linked. So this one is 58, right? And find the arc of DA. So let's look at this. Well, these two, C to A, if we look at it right here, I'm going to draw this little part right here so you see that. Well, this is half of a circle. And we've also spent lots of times with that. So we know this is 180 degrees right here. So all we have to do is 180 degrees minus 58. Okay, and what do we get? We get 122. Okay, all right, let's move on to our next one. Okay, so let's talk about angle addition. So to measure the arc, find by two adjacent arches. So what have we used the word adjacent before? That means they have to be next to each other, kind of like next door neighbors, or touching. That's another way we use to describe them, arches, by adding the two arches together. So here's our formula. We have A, B, and C. Let it with our little red marks right here. So all we have to do is our measure of arc A, B, C. And remember, M stands for measure. We remember that from all our angles. And this little symbol just says arc, right? So this is the 3. The B is in the middle. So that means I'm going from here through B to C, just like we've done with angles on triangles. Anything. So this tells us I'm going this way as opposed to going around the other way. Okay, so the measure of ABC is equal to the measure of AB. And I just got a little arc right there, plus the measure of BC. Okay, so that's just saying I have to add the two together. All right, let's do the next one. Finding arc measures now. So now we need to find the measure of arc U. So U is right here in the middle. Okay, so this is where we're talking about center point U, right here in the center. And so now we need to find the measures of the arcs all around U in the center. So we have ST, so ST is right here, right? So we have 72, and indeed, remember what we said, it's the same as the central angle, so this is going to be 72. Then we have QRS. So QRS means I'm going this way, right? Everyone see that? Okay, so what does this make right here? It makes 180 degrees. So this one is, or half of a circle, right? And so the last one, we have the measure angle TUQ. So angle TUQ. So it means this angle right over here. Okay. And if you notice, these are being shown in 3 different ways. So that means you'll be able to see these 3 different ways on your assignments and possibly your tests as well. So it's just asking you same things, just in a different way. Okay. So for this one, we need to look this side over here makes another 180 degrees. So we're just going to go 180 and we're going to subtract 72 from it. So we get this angle to be 108 degrees. All right. All right, moving on. So now we're going to do a little bit of algebra with our angle addition. Okay, so this asks me to find the value of a variable, Well, there's only one variable, x. So what do we notice though? We have an X here, an X there, and an X here. Well, together I make a complete circle, which is how many degrees? 360 degrees. Remember, we talked about this before. So all I have to do is add up all my expressions and put them equal to 360 to solve for my X. Okay, so I'm going to start right down here. So let's go 2X plus 60 plus X plus 40 plus 3X plus 20 is all equal to 360. So when you have terms like this, make sure you get all of them. Figure out a way to start. Make sure you capture all your terms. So now let's combine like terms. We got 2X, 3X, and then another 3X. So we have 6X, and we have 60, 40, and 20. So that's 120 is equal to 360. Well, now I'm going to move my 120 on the other side. So I get 6X is equal to 240. Well, I'm just going to divide by 6. And that gets me X is equal to 40. Okay. Let's do another one. Okay. So for this one, I still have a variable that I need to find. This time I have A. But what do I notice about these? The two that I'm asking about are only on this side. So this is equal to 180 degrees. So I just put both of my expressions. 2A minus 45 plus A is equal to 180. All right, so I have 3A minus 45 is equal to 180. We're going to plus 45 to the other side. So we're going to end up with 3A is equal to 225. And then we're just going to divide both sides by 3. So we have A is equal to 75. All right. Moving on. Now let's do some arc length. Now. Okay. So arc length is a fraction of the circumference. So if we look at this, I've highlighted our arc length right here in red. So it's just, if the circumference is the whole pie, if we think about it, a whole piece of pie, well, then the arc length is just this little fraction or this little portion of the pie. Okay, and remember, it comes from our central point. So it is a product of a ratio. We've done ratios before. A product of a ratio. And we've done proportions and all different types of ratios before. So I'm going to write our little formula here. So we have the length of AB, of arc AB, to be exact, is equal to the measure of arc AB over 360 degrees, so a full circle, times 2 pi r. And we see we have our r shown right here in this example. Well, because I have 2 pi r, what do I remember about the diameter also? That means I can also rewrite this formula to include the diameter if it's given to me. So I'm going to have the length of arc AB is equal to the measure of arc AB over 360 times pi times the diameter. Okay, so now we have it set up so that we know no matter which way we get our values. Okay, so let's work some examples of this one. Okay, so what is the length of the arc shown in red? Here's our red part. So it's going from X, P to Y. Okay, so let's figure out, use our formula. Going to write it down for us. Remember to make sure you always try and put your formulas in your notes. It helps you. And it always helps you on your tests, right? And your homework assignments. Okay, just make sure you are. So if we notice, it says X, P, Y, arc X, P, Y is equal to 240 degrees divided by 360. And so we notice that the radius is 15 centimeters. So that means this side is 15 and this side is 15. So the radius should be the same, right? It's from the middle. So we have 2 pi times 15. Okay, so I'm going to simplify right here. Simplify. And so I'm going to reduce that down. So it's going to be 2/3 times 2 pi 15. And that means I'm going to carry it through. And so I'm going to get 10 times 2 times pi is equal to 2 pi. Okay. Let's do another one. Oopsie. Mouse is being stubborn right now. Okay, moving on to the next one. So for this one, we're going to find the length of the arc shown in red. We're going to leave this number in our terms of pi. Okay, so what do we notice about this one? We notice this one is a semicircle, or our diameter is shown. So we see a right angle here. So we know this is a right angle also. So we know this is 180 degrees right there. But it's not asking us for that one. It's just asking us for this part right here, which is 90. They've highlighted. So let's write our formula. And I'm going to say length of arc XY is equal to 90 over 360 times pi times 16. Okay, so let's simplify it down. So I have 1 over 4 times pi times 16. Because remember, this time I have the diameter. Okay, so my formula was a little different. Okay, and then if I multiply that, I skipped that step to show you last time, so I'll make sure we know it. So 16 times 1 is 16, right? Divided by 4 is 4. So I have 4, and then I have pi, okay? And I'm going to put it in inches because we want to get in the habit of labeling our terms, okay? All right. Let's do another example, okay? Find the length of the darkened arc. So this part is just darkened. It's a little bolder, if you can tell. So we need the arc length. So I'm just going to put the length, arc length. I'm going to put that right there. Okay. Is equal to 90, which is our angle right here, over 360 times 24 times pi. So when we simplify it, that's going to get us down to 6 pi. Okay, you can do this part in the calculator if you want to. You don't have to do it by hand. Okay. All right, so that's all for our academic. If you're pre-AP, still hang on. If you want to stay on academic, you're more than welcome. There's a couple problems we're going to work. I think you'll like them if you do. Okay, so for this one, we need to find the distance. We have a 2 feet wide circular track for a camera dolly. A camera dolly is just this little cameras on a little dolly like you use for moving, but it just goes around the track. It's set up for the movie scene. The 2 rails of the track conform concentric circles. That means they surround each other. The radius of the inner circle is 8 feet. How much farther does a wheel on the outer rail travel than a wheel on the inner rail of the track? So the outer rail is over here, you see them, and the inner rail is over here. And remember, this track is 2 feet. So one of our problems usually on word problems is just trying to visualize on how to set it up. So I made 2 little circles right here. So I'm going to try and make our center pretty close to the center. So it said our radius was 8 feet. So I drew my 2 circles to represent my track, okay? And then this outer one is 2 feet wide, it said, okay? All right. Okay, so let's talk about our first step. So the first step is we need to find the distance of the first track. So let's find the distance. Find the distance. The distance of the first track. The first track. Of the first track. Okay, so I'm going to start with the circumference, right? Because that's how I find my distance all the way around my circle. So it gives me the radius, so I'm going to use my radius formula. So circumference is equal to 2 pi r. Okay, so now I'm just going to plug it in. It's equal to 2, and I'm going to put my 8 right next to it. Okay, times pi. So I'm going to leave it just like this, 16 pi. All right. Now, next step is to find the circumference of the outer circle. Find the circumference. I should have just wrote C, right? Instead of writing this all out. You all can do that. You don't have to keep writing circumference. Just write C, capital letter C, of the outer circle. Okay. So if we know the radius of the inner circle is 8, and we know this is 2 feet wide, that means this to out here would be 10, right? It'd be 8 plus 2. 8 plus 2 would give us 10, all right? So that gives us our new radius for the outer. So this radius, I'm going to put right here so we know, is 10. And we found that by saying x plus 2, just in case you forgot. Okay? So now let's plug that in. We have circumference is equal to 2. Now I'm going to put my r times pi right there. So we have 2 times 10 pi, which is equal to 20 pi. Now, the next step we need to do is it said we need to find the difference between the wheel that touches here and touches here. Okay, so we need to find the difference. Find difference. Difference between the two. Between the two circumferences. And I did it again too. I should have just wrote C. All right, so we have 20 pi minus 16 pi is equal to 4 pi. Now finally, the last step, we're going to put that in the calculator. We're going to put our 4 pi into the calculator. And it's going to give us a value of approximately 12.566. Make sure you do it in your calculator. Make sure you get the same value. And I'm just going to round this to feet. And so it's going to be 13 feet. Okay? Don't forget to keep starting, use your units to help you. All right, last one. Okay, I don't know how many skaters we have out here, but I thought this one must be fun. So we have inline skate wheels that have 44 millimeter diameter, and that's millimeter diameter. How many meters will Kylie travel after 5,000 revolutions of the wheels on her inline skates? So I gave us a picture of what inline skates look like, just in case we don't have very many skaters out here. We need to round your answer to the nearest 10th of a meter. Okay, so the biggest thing we need to know, it said this is the diameter. So it's talking about, and that's a little hard to tell, but we're highlighted. So it's saying this right here, well, let me highlight it on the thing, of our wheel is 43. Okay, so let me go back. So I'm going to write that over here so we know. So the diameter of our wheel is 43 millimeters. And this is important because it's asking us to find the value of how much she travels in meters, okay, to the nearest meter. Okay, so we have that. And I'm going to draw a little wheel up here just to make sure we're all on the same page. Okay, this is 43 in millimeters. Okay, so let's use our circumference. So we have pi times diameter. So we're just going to plug in our 43 pi. All right, well, we're not done. We need to go on and get this into a value and not leave it as a pi. So we have put that in, 43 pi, Get your calculator out, and you should get roughly, and I'm going to do it all the way out just to make sure I don't lose anybody, because that's as far out as it goes. And this is in millimeters, right? So the next thing, remember our circumference is like the perimeter. So if it's going to rotate around, that means it's going to do one circumference each time for each rotation. So what I'm going to do is I'm going to multiply 135, and I'm just going to write all my little terms out. You don't have to, okay? Millimeters times 5,000 rotations, or revolutions actually, because that's just how many times it's going to spin around, okay? Or how many times it wants us to spin around. So that's going to give us a really big number in millimeters. So everyone do that one in your calculator. Okay, now the last step, it asks us to find to the nearest meter. So does everyone remember how we convert millimeters to meters? 1,000 millimeters is equal to 1 meter, right? So I'm just going to take this and I'm just going to set up a little ratio. You can do it whatever way you feel comfortable. I'm going to do it this way. So I have 1,000 millimeters. Meters. All you have to do is divide this by 1,000, and you are going to get 65.4, and it says round to the nearest 10th when it's actually 4, so it's rounded to the nearest 10th. So we have 675.4 meters, okay? And you could have done it the way Ms. Clay did, or all you have to do is divide it by 1,000, and you'll get your number, okay? That's all for today, Longhorns. I hope you have a great one. If you have any questions, contact your teacher.